Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Today, we are going to discuss various functionalities for performing statistical operations using NumPy. Statistics is a branch of mathematics that deals with collecting, interpreting, organization, and interpretations of data. Initially, when we get the data, instead of applying fancy algorithms and making some prediction, we first try to read and understand the data by applying statistical techniques. By doing this, we are able to understand what type of distributions data has. Dear friends, let's just start with descriptive statistics. Descriptive statistics involve summarizing and organizing the data so they can be easily understood. And it's unlike inferential statistics seeks to describe the data, but does not attempt to make inference from the sample to the whole population. Here we typically describe the data in a sample. So this generally means that descriptive statistics, unlike inferential statistics, it's not developed on the basics of probability theory. And of course, these descriptive statistics are divided into two categories. One is measures of central tendency and measures of variability. So under measures of central tendency, we have mean, median, mode. And coming to the measures of variability, that is spread, of course, standard deviation comes. So let me just start it, how to find a mean of a data. Dear friends, mean, or which we just specify as like average, is a central tendency of a data. That is a number around which a whole data is spread out. In a way, it is a single number that can estimate the value of the whole data set. And here it is the one given in the example that we have an array as with 5 elements, that is 2, 4, 8, 10 and 12. And we are just going to store it in a variable called my_array. And to identify the exact mean, of course, we have to sum all this value and divide it by n. So where the n is number of elements here, of course, 5 elements. And see here, dear friends, on to the resultant, we just get the mean of these array. And which array? my_array, where it just stores these 5 values. And let I just execute here, dear friends, and see here, I'm coming to the mean of these data. The data is 2, 4, 8, 10 and 12. Of course, we have to sum it and divided it by 5. We just get the resultant 7.2. And here we have already passed the exact data. Of course, even though we can also have a random set of data where this would be a 2-dimensional array. And here it is of 2 rows and 3 columns. And see here, dear friends, this exact function, we can just do it in 2 ways. That is across the rows and across the column. In 2-dimensional. To find across the column, we have to pass the exact parameter of axis is equal to 1. And similarly, to find the mean across the rows, you need to pass 0 to the parameter, axis parameter is equal to 0, the value. Okay, now let me just take an array randomly. Of course, the random number, it is just going to be between 1 to 20. And the size of the array, it is of row comma column, that is 2 rows and 3 columns. And let me just identify the mean by using the function np.mean. And here we are having the 2 types of things. One is with the column wise, as axis is equal to 1 and the row wise axis is equal to 0. Let I just execute. Kindly just have a note of it, dear friends. as we have done it randomly. Yeah, this exact random array, it just has two rows and three columns. And when on just making it towards the column wise, this is the first column, and we just have 8 of 6 and 9 and 12 and 18 of 16, so that we just get 8 in the exact row wise, and 15 and 4.6 as a column wise. So row wise, as two rows we are having. Okay, so yeah, next we are just going to identify the median. Dear friends, median is the value that divides the data into two equal parts. That is, the number of terms on the right side of it is the same as the number of terms on the left side of it when data is arranged in either ascending order or descending order. And the median will be the middle term if the number of terms is in odd, and the median will be an average of that middle two term if the number of the term is even. Okay, let me just identify the median of a given values. So here the given values are the same thing which we have used it for mean value. Yeah, so 2, 4, 8, 10 and 12 are the given values. And yeah, here is the function np.median, where we can easily identify the median of the NumPy array. Okay, so here let I just execute it and see here, dear friends. Yeah, as we are having it in odd sense, yeah, the center value is the exact median value. And of course, the next one, we are just going to identify the two-dimensional type of array. Okay, and where it is just going to have a random number of 1 to 20, between 1 to 20, and the exact size of that array is 3 into 5. And kindly observe, dear friends, when on just making it 3 into 5, of course, on the row wise, we just get 3 rows, of course. So here, according to the axis is equal to 1, it just makes the row wise towards the column, and across the row towards the column here, it just comes the axis is equal to 0. Okay, so yeah, here also we just pass the exact median as the function, and let me just explore here for a two-dimensional array. And we just got the randomly integer value from between 1 to 20, and we are having the two-dimensional of 3 into 5 the size, so that it is 3 rows and 5 columns. And kindly just have a note of it, dear friends, as we have 3 rows. Yeah, for each and every row we are just getting the median value here. So for kindly just observe, so here for this value, yeah, 12 is the median value, and for the second row we are just having the 14 as our median value, and for the third row we are having 7 as the median value. Okay, and of course across to the column, so we just passing it to the 1, and across to the row we are just passing it to by axis is equal to 0. And kindly just to see here, dear friends, when we are having across to the rows, yeah, we are having 5 columns, and kindly just observe to this exact columns. So first column 3, 14 and 18, of course 14 is the median, and 15, 18, 14, 15 is the median. And here 12, 6 and 6, of course we just have 6 is the median. And 2, 5, 6, 5 is the median. And to the last 14, 16 and 7, so 14 is the median. So this is how we can observe and we can identify the exact median value of an two-dimensional array. And next, let me just have the minimum and maximum values. So what is the minimum value of an array, given array? So here, yeah, it can be identified by using the exact function as max. And to the same, the minimum function, it just returns the minimum value of the given data. And here it is the given data that 2, 4, 8, 10 and 12. Yeah, of course, we want to identify the minimum value, and here it's so we are just getting the 2 as the minimum value of this given data. And of course, we are having one more function where we can identify here so as the maximum. So before that, let me just make a attempt of a two-dimensional array where we can just have the size as like 3 into 4. And of course, here also the same example of randomly integer just between 1 to 20 we taken as our data. And with this, when on just finding the exact minimum value, yeah, we can just go with two main functionalities. One is row wise across the rows or across the column. And here to the dear friends, kindly just observe by passing 0 or 1 as values for the axis attribute of this minimum method, yeah, you can identify the values across all over rows or columns. And see here, dear friends, the value of 1 for the axis attribute returns the minimum value across all columns. And whereas the axis is equal to the value of 0 returns the minimum value across all rows. And let I just execute it. See here, dear friends. So when coming to this two-dimensional array of 3 into 4 size, and here we have 3 rows and 4 columns. When we just take it across the column wise, yeah, we have the rows of 18, 18, 8 and 18. So of course 8 is the minimum here. And when coming to the second row, 5, 8, 17 and 8, of course 5 is the minimum. And to the last 5, 15, 4 and 19, of course 4 is the minimum. When across to the all rows, yeah, we are just going to have 4 columns here, and to be true, yeah, 5, 8, 4 and 8 are the minimum values towards all across the rows. Fine. Now let me just move on to identify the max value. So that is maximum of that given data here is 12. And kindly just have a note of it, dear friends. We are just passing the function Amax for identifying the maximum value across these given data. And next, coming to the maximum, identifying the maximum value in a two-dimensional array. And the dimensional of the size of the dimensional array is 3 into 4. So here we just get 3 rows and 4 columns, obviously. And yeah, to the same, we are just going to store it in the variable my underscore array. And then when on just passing the function a max to that of NumPy, yeah, with two functionalities. One is axis is equal to 1 and axis is equal to 0 according to the column wise and across the row wise. Yeah, here we get the maximum value. And dear friends, coming to the next one, next type of this statistics, so which we just say measure of spread. And yeah, this measure of spread, just we have a standard deviation. Standard deviation is the measurement of average distance between each quantity and mean. That is how data is spread out from the median, from the mean. A low standard deviation indicates that the data point tend to be close to the mean of the data set. And while a high standard deviation indicates that the data points are spread out over a wide range of values. And let me just identify the standard deviation, dear friends. And yeah, let me have an example here. So this is the given data 2, 4, 8, 10 and 12. Of course, here to identify the standard deviation, we are just going to pass the standard function std, the function. to find the standard deviation of a NumPy array. And here the given array is my underscore array. When I'm just passing that my underscore array to the std function, that is standard deviation function. Let me just explore the resultant and see here, dear friends, this is what the standard deviation value of the given array, and the array is 2, 4, 8, 10 and 12. And of course, we can also identify the standard deviation of a two-dimensional array. And of course, here the size of the two-dimensional array is given by 3, 4. And when on just making it towards across the row wise and across the column wise, we can identify the standard deviation of the two-dimensional array by making assumption as 1 to 20 as the given value. So see here, these are the values of a two-dimensional, and here it is just giving the 3 rows, that is across to the top column we just get the 3 values of an array, that is standard deviation of them across the column wise, and here we just get across the row wise. Fine, dear friends, next we are just going to find the correlation. See, correlation is a statistical technique that can show whether and how strongly pairs of variables are related. The main resultant of the correlation is called the correlation coefficient. Of course, if the exact correlation, actually the ranges of it just from -1 to +1. So the closer R is to +1 or -1. So the more closely the two variables are related. And here, if the exact value is close to 0, it means that there is no relationship between the values. And if the value is positive, it means that as one variable gets larger, the other gets larger too. And if the exact value is negative, it means that one gets larger, the other gets smaller, which is just to specify the inverse correlation. And I just specify it again, dear friends. If one data increases, the second data it's also increasing. It is said to be as like positive correlation. And if one data is increasing, the other data is decreasing, is in the sense inverse wise. So it is specified as like a negative correlation. And so that we need here two datas. Of course, one given data here we are just getting specified as 1, 3, 0 and 0.9 and lastly 1.2. And here we are just specifying it as an array 1. And the second array here we are having as like -1, 0.5, 0.2, 0.6 and 5. Of course, let me just get it displayed here as this is what A1 and A2. And when on just identifying the correlation, yeah, we are just going to pass the exact function correlation. So here we are using the correlation method and passing it the two NumPy array between which you want to find the correlation. And here it is the two array as A1 and A2. And kindly observe, dear friends, when on just passing it, yeah, we get the correlated value as 7.04. And hope, yeah, of course, it is positive. So it means that one variable is increasing. And if it is increasing, yeah, of course, the second value would also get increased. So that has come, it just to specify as positive correlation. And next we just go for identifying the unique items. And if it is not a unique or anything, yeah, let me just say how many times of occurrence it has. So to identify, let me just go with the number of counts. Okay, so see here, dear friends, let me just identify the unique value by providing the method unique. And to find the values in the NumPy array, yeah, here the given NumPy array as 5, 8, 7, 5, 9, 3, 7, 7, 1, 1, 8, 4, and 6, 9, and 7, 3. Lastly, so here I just want to know what are all the items that are unique, that here I should not get any duplicate value. So only the unique items it has to be printed. Yeah, for that we are just going to pass the method unique. And when on just passing the method unique, yeah, here we just get only the occurring of ones alone. So here we just get 1, 3, 4, 5, 6, 7, 8, and 9. So these are the unique values that available in this given data, which we just specify my underscore array. And kindly just have a note of it, dear friends. To find the count of every unique item in a NumPy array, you need to pass the array to the unique method and pass true as the value for the return counts attribute. And see here, to this given number itself, see here, that is 5 is occurred twice, and 7 it is occurred 4 times, and when coming to the number 8 it is occurring twice. So how many times the exact unique value has been provided? So that we have to identify. So yeah, of course, we can just get it done by using the both functionality. Kindly just observe it, dear friends. So here we are just going to have the unique items and to its occurrence. And how this occurrence is going to be happening is, of course, the unique method in this case returns a tuple which contains a list of all unique items and corresponding list of counts for each unique item. So here is the, I just execute it and see here, dear friends. Yeah, we know that these are the unique items as like 1, 3, 4, 5, 6, 7, 8, and 9. And below is the exact list where it just specify number of times of each unique item. And kindly just observe. So for 8 here, we just get twice it appearing. And so here, yeah, as like this and towards this. And when coming to the value 7, yeah, it is occurring 4 times. Yeah, let me just observe here. Yeah, here it is the 1 and the second occurrence and third occurrence. Of course, here it is the fourth occurrence. And one way you can get the count value against every unique item, which is creating an array of array where the first item is the list of unique item and the second item is the list of count, by making use of a function called as array. And see here, dear friends, when on just passing it, yeah, of course, see here, one is as like unique item and the second one is the counts. Yeah, this is the resultant from the 13th cell. And when I'm just making this, yeah, of course, we can just get it done with an as array. It is just getting created. And here it is, so let me just display the array here. And if you want in another way, yeah, of course, you can also make use of transpose the array that contains the list of unique items and its counts. So making it transpose, yeah, in that output, in the execution of that resultant, and kindly just observe here, dear friends. So you will get an array where each element is a list and the first item is the list in the unique item itself, while the second is the count of its. So let me just have it, and here we are just only including this dot and an uppercase of T, which is just specify the transpose. And see here, dear friends, the 1, 3, 4, 5, 7, 6, 7, 8, and 9, and here we just get the occurrence, number of occurrence. And next come the dear friends, kindly observe, we are just going to create a CSV file by using a NumPy. Yeah, this can be possible by making it with a to file function. See here, dear friends, this CSV file that is as like comma separated variables. This file are an important source of data. So the NumPy library contains functions that allows you to store NumPy array in the form of CSV files. And here the NumPy module also allows you to load CSV files into NumPy array. So both the things it is possible. And let me just start it with how to save a NumPy array in the form of CSV. And you can use the to-file method and pass it to your NumPy array. And kindly just observe it, this example, dear friends. Yeah, we are just going to have it randomly 1 to 20, that is the number between 1 to 20, and the size of the two-dimensional array is 3 comma 4, so 3 rows and 4 columns is there. And let me just create it as like an array, and of course we are just going to store it as like an array in a CSV format. And yeah, each and every data which we are going to store it is with a separator of a comma. So of course, let us just execute this file and see here, this is the one which we can just have 14, 8, 14, 16. So this is the first row, and second row as 12, 13, 14 and 4, and the last third row is as like 16, 14, 6 and 17. And here though, dear friends, this is the exact array which is in the size of 3 comma 4, a two-dimensional array. When I just want to save it as like a text file, yeah, you can also save it in the form of text file, where one and only things, kindly just to see here, this is as like we are going to have it as like a txt, that is dot save txt. And to store this two-dimensional array in the form of multiple rows in a CSV format, yeah, you can also use this save text method from the NumPy module. So here, let me just make use of this. From where you are just getting, yeah, of course, this is the array, that is one among the parameter, and we are including the delimiter, thus one among the thing, and of course, this is stored as like an file. And what is the file? Yeah, it is array2.csv. Yeah, dear friends, this exact array2.csv would be in a text format, and my underscore array.csv, it would be in a CSV format. Okay, and let me just load it once for all. If you want to load the exact file and if you want to know what is the exact file having, yeah, you can just make use of the method as get from the text, or you can just get it from the CSV file as like you can just explore it in another format it is there. So here we have to specify the delimiter. Yeah, of course, we have used the comma as the delimiter to store it in a text file. And here, so dear friends, to load it once for all, kindly just have a note of it. So this is the exact data that has been loaded. Sorry, that has been saved it as like an array2, and now it is just loaded. And of course, we have loaded the array by using the gen from text method. Hope actually, dear friends, this would be very useful for making use of statistical operations by using NumPy. And kindly subscribe the channel on never missing any updates. We are just going to explore it new concepts coming up. And happy learning, dear friends. Thank you.